You don't run.
Thank you very much for coming, everybody. Taking a break from looking at your March Madness brackets and coming to take a look at drought, which some of you may be experiencing in your brackets themselves. What we have is a schedule up here of our seminar that I wanted to plug before we get to Dr. Fisk. And today is of course, Dr. Lanny Fisk, but next week, or I should say, next week, we have Dr. Miranda Frem from USGS, who's the distinguished lecturer for the Groundwater Resources Association. We were lucky enough to get her to speak with us, speaking about their public drinking water supplies in California. And then we have a lot of other water talks coming after that. Brian Bergamaschi from USGS. Dr. Charles Real, who did work with the Department of Conservation.
No.
Did I get that right?
CGS.
He's actually not a retired astronomer. That's not his #1 thing, but that'll be for later. John Singapore is going to come also to talk about mineral hazard studies. And then also our very own Dr. and Dr. Kaufman. So write those dates down, look at our website, it's coming, and then we got a great rest of the semester here. But for this particular talk, it has as you can see, has great interest in a wide variety of subjects. We're talking about drought, the indications of drought. And Dr. Lanny Fisk actually has over 40 years of experience as either a professor or consultant or as a paleontologist. And actually has, he initially got his degree in 1971. I was born, actually. That, if anybody cares. It's all about me.
I bet Dr. Fisk gives it to you.
From Andrews University, PhD from Loma Linda University in California, 76. Some postdoctoral work at Michigan State University. Please find a seat, get comfortable. But has also taught at Walla Walla University and also at Loma Linda University and American River College. But right now he is the head geologic consultant at Paleo Resource Consultants, which is stationed in Auburn, California, doing projects all around California and beyond. So with that, this is a fantastic subject. He's co-authored over 80 scientific publications, 200 consulting reports, if not more. So he's got a wealth of experience. We're lucky to have him here. And with that, I'll ask Dr. Fisk to come on up.
Well, Dr. Tree's off to a terrible start. You mentioned the drought in your basketball brackets. State University. The number 2 team, they got wiped out by the number 15 team in the very first round. Very disappointing because Michigan State was predicted by 24% of the nation and 24% of the brackets to go all the way, and they get wiped out in the very first night. So I'm sorry you said that.
It's like our water supply.
But I also should point out probably that this is going to start at 5 o'clock, the seminar is. And so we've got a while here to. Anybody have any ideas of how we could fill in this time? What I want to share with you in this seminar is the story of droughts, but not the one that you're currently suffering through, those that are. I don't know about you guys, but yesterday we got a real gully washer in Auburn. I mean, we probably had 1.5 inches of rain in less than an hour. It just really came down. But what I'm going to talk about is that there's a record of many more droughts in the past, and they've been a lot worse than what we're experiencing right now. Todd, if I can.
Yes.
I'm telling you the wrong way. If the title page were actually correct, it would have Dr. David Maloney's name in here, who's not really a doctor yet, but if he's on this title page, he probably ought to be treated like one at least. And Dave is one of your graduate students, and he's been involved in this research from the very beginning, along with many other people who work at the company that both Dave and I work at, Paleo Resource Consultants, that Dr. Green was explaining. We do mitigation paleontology, that is salvaging of fossils from large construction sites. The big projects we're working on right now are several highway construction projects and a large Air Force extension out in Nevada. So those kinds of things keep us busy. Just a brief introduction to what I want to talk about. I'll talk briefly about the recent droughts, and then we'll jump into the Central Valley and look at Caliche. I have some Caliche samples up here on the table that you might want to take a look at later. It's a different Caliche than most of you might be familiar with, but it's one I think that has a very important story to tell. We'll relate that Caliche to the stratigraphy of Central Valley, specifically the Pleistocene stratigraphy, and put it together as a picture of Pleistocene droughts that are much worse than anything we're experiencing today. So unless you're taking 20 credit units, or you've been hiding in a cave, or you've been spending 24/7 on Instagram, you're aware that we are currently experiencing severe drought. This is back in October of 2015, and it certainly would have changed today, but notice where California is relative to the whole rest of the nation. We are definitely, and have been for the last 4 years, in what's known as a severe drought. But the question is, how severe? How severe is our current drought compared with droughts in the past? Well, you read in the paper or you hear in the news that this is an exceptional drought or an extreme drought, an unprecedented drought, a record-breaking drought, the worst drought in recorded history, or even the worst drought ever. And I say to all of those, BS. That's bad science for those of you what I intended at least. It's bad science because when we look at the fossil record and the geologic record, we see that there are droughts that were far worse than those we see today. Specifically, if we go back to the Pleistocene Ice Age, and the Ice Age is there in quotations because I want to make sure that you're not confusing it with the movie. All right? The ice... Wait a minute. No, we are not confusing this. Don't you remember the movie? At the beginning of the movie, Sid was going in what direction? South. Manny was going north. Why? The weather was changing. It was getting colder to the north, and that's where Manny wanted to be. And poor Sid wanted to go south, but got all confused like Sid only can do, and ended up going north with Manny, and that's what the whole movie is about. What's the next movie after the Ice Age 1?
Ice Age 2.
The Meltdown. Ice Age, the Meltdown. That's exactly what I'm talking about. It's Ice Age, the movie. The changing climatic conditions during the Ice Age. So if you don't get anything out of my seminar at all, please go home and watch the movie because you'll get the story out of that. What I'm really trying to say is that the Ice Age has been misnamed. The Pleistocene was a time of complex climatic changes, both cold and warm. And what we have done is overemphasize the cold periods. The Ice Age, yeah, there was ice, but there were also very warm periods. And that's what I want to emphasize today. Cold and warm during the Ice Age, not just ice. In his book, Ice Age Fossils, Alan Holman, a vertebrate paleontologist from Michigan State University, who's no longer in the bracket, but one of my major profs when I was back there. He reminds us that the presence of such species as caribou, musk oxen, woolly mammoths, snowshoe hares, tundra lemmings, all of those fossils indicate that there was a harsh, perhaps even savagely cold climate during part of the Pleistocene. And that's where most books on the Pleistocene stop. They emphasize that harsh, perhaps even savagely cold climate that resulted in caribou and musk oxen and woolly mammoths and snowshoe hares and tundra lemmings coming all the way down to the southern part of the United States. But what's the rest of the story? Well, the rest of the story is that there were other times during the so-called Ice Age when we had tapirs and armadillos and jaguars and peccaries, capybaras and land tortoises, all in the northern part of the United States and even into Canada. It must have been much warmer during those times. Sid would have been happy. Manny would have been sad. The modern relatives of those species, the tapirs and the armadillos and so forth, they cannot tolerate freezing temperatures today, and presumably they would not have been able to exist in the past if the temperatures dipped below freezing. For the quiz that'll come at the end, that's Kibbard's rule. It'll be in the matching portion of the quiz. Keep in mind, much warmer. Now that's the part of the story that you usually don't read when you read about the Pleistocene Ice Age. Again, it's there in the movie, but it's overlooked most of the time. The fossil remains of these warmth-loving creatures indicate that there were times during the Ice Age when the climate was much warmer than current winters. Did you get that? Between the cold periods, it didn't come back to normal. It came back to a lot warmer than normal. It wasn't cold and normal, it was cold and hot. If global warming results in return to those kind of winters, then I may go back to Michigan. But as a kid growing up, I can remember only two seasons, the winter season and the mosquito season. That was the only two that I remember from back in Michigan, so I don't think I'm going to leave California very soon. The record in the Pleistocene, or at least back to about 350,000 years ago, is well recorded by oxygen isotopes. And the oxygen isotopes tell us that if we have periods of very cold temperatures, such as these, we've also had periods of time in which we had very warm temperatures, such as these. There's a couple things I wanted to point out. First of all, notice how quickly it changes from cold to warm, from cold to warm, from cold to warm, from cold to warm. Those are extreme temperature changes in short periods of time, hundreds, maybe thousands of years, but extreme temperature changes. If this is normal again, keep in mind, this is Ice Age, this is glacial maxima. Temperatures didn't come back to normal. They swung all the way over to extremely warm during interglacial periods of time. And it's these interglacial periods of time that I'm particularly interested in. In our work up and down the Central Valley, we have seen over and over again thick Caliches, similar to the ones that I put up here on the table, and we'll come back and describe Caliches here in just a moment. But very thick, platy Caliche, forming distinct layers. And where those thick Caliche layers are is right at this level. Right at the top of a sequence of sediments that's been interpreted to be glacial deposits. So we go from glacial deposits to a very thick Caliche. Now I don't see anything in the fossil record or in the geologic record that isn't going to be useful and give me some information on what's going on at that time. So on all of our projects, people like Dave and people who work for him have collected samples of the Caliches, regardless of where they are in the sequence. Most of our work where we found Caliches have been here in the Central Valley, specifically along the west side of the Sierras, in what's known as alluvial fans. And the alluvial fan sequences are a record of what's happening during the Ice Age, during the Pleistocene, up here in the top of the Sierras. So sediments that are being reworked, eroded by glaciers, alpine glaciers, up here in the Sierras, are being transported down into the valley and deposited as fan deposits, alluvial fans. We can see them on geologic map of California. It's all these yellow deposits. And notice that they're very fan-shaped. And we call them, again, alluvial fans. They're a record of what's happening up in the mountains, because whatever glaciers are affecting up here get washed down streams and canyons and get deposited out here in the Central Valley. And on those alluvial fans, roads go through, energy plants are put in, pipelines cross those fans, and when they do, we see the stratigraphy well exposed, and we see the Caliches exposed. So again, in the subsurface, each of those fans will have a series of sedimentary deposits which have been given names, and we'll come back to that in just a moment. But what we're interested in is at the unconformable contact between each of those sedimentary bodies, which represent a glacial deposit. Often there are calcite at the top, which is caliche, or platy caliche, which I prefer to call calcrete. This is a typical measured section from one of our projects in Central Valley. And what it shows is there's lots of channeling that takes place as streams continue to not only deposit but also erode on those alluvial fans. And at the lower part we have the early Quaternary, early Pleistocene Turlock Lake Formation, overlain by the middle Pleistocene Riverbank Formation, overlain by the late Pleistocene Modesto Formation, with then some modern soils on top. But what's of most interest to us was these platy Caliches, which are found throughout the sequence, but also almost always found at the top of the sequences, such as this one here at the top of the riverbank. Now, when we think of Caliche deposition, we don't usually think of platy Caliche, but this is what it looks like when you look at a cross-section in a trench. These little marks are from the trencher that cut this trench, and you see this white line, which is the platy Caliche. The Caliches down here are lining burrows. The burrows open back up to the surface, so we're talking about this little squirrel looking for his acorn and other animals that are burrowing to get out of the harsh climate above. And they're burrowing probably before the caliche is deposited, which is deposited during the warmest and most arid part of the event. Another view of a platy caliche starting over here and coming through here, but you can also see the platy caliche around each one of the burrows. So what is this caliche telling us? That was the question. Many people asking it. We decided to take a look at it. When you look at it up close, some of it even has lots of little eggs. We don't know exactly what these are. If you've got ideas, please share them with us. We think they probably are some kind of a crustacean, something like a fairy shrimp, something like lives today in vernal pools. And then just before the vernal pool dries out, they lay thousands of eggs that then the next spring, when rain comes, those will all hatch and the little fairy shrimp will come back to live in that environment. But this is the platy caliche. What kind of environment do you expect that kind of platy caliche to be deposited in? Well, it's not typical. This is a typical soil profile in which we have minerals from the upper part of the soil being carried downward by rainwater, and the minerals being deposited down here in the B horizon or even in the top of the C horizon. And that we call caliche. So caliche typically is deposited down here, but that caliche is disseminated. It's mixed in with the soil. It's not the platy caliche that we're talking about. In fact, it looks very differently. It's not that kind of caliche. This is the type of caliche that's in the B or C horizon. It's disseminated. Sometimes it makes little nodules. But that's not the platy caliche that we're looking at, that I prefer again to call calcrete. The calcrete instead is formed during a very arid period of time in which those minerals which are dissolved into groundwaters are transported back to the surface, and then by evaporation they're deposited at the surface. And that surface calcrete is what I'm calling the platy caliche. What kind of environment might produce that kind of thing? Well, it's this kind. Again, platy caliche, which lines the burrows, makes a half a centimeter or half an inch thick layer. You might find them in an environment such as this. Anybody can recognize where this picture comes from? Carrizo Plain. You may know the Carrizo Plain because of the famous location where the San Andreas is offset streams. But there are large playa lakes out here. These are dry, usually about 10 months out of the year, and in the last 4 years they've been completely dry. But I'm old enough to have been around when there was 6 feet of water completely covering this and all the way up past the road. So there are periods of time when these playa lakes are very much lakes, and they dry up. The minerals are brought to the surface through evaporation, and they form a crust, a calcrete layer. So there are vernal ponds in the springtime, this time of year, but most of the year they're dry lakes or playas. So, what kind of environment do we interpret these playas, or these, calcretes to have been deposited in? Well, that kind of environment. A playa lake. Vernal pond part of the year, but dry, arid, hot the rest of the year. So what we have done is collected sediments through the sequence from the Turlock, from the riverbank, from the Modesto, and we've collected sediments as well as caliches. And we wanted to see what the difference in microfossils were between these sediments and the caliches, to see if we could see how the environment changed during that time. The microfossils that we retrieved were primarily pollen and spores, such as this one from the sediment. And out of the sediments, we get about 50 to 60 different kinds of pollen, but the most abundant ones out of the sediment are oaks, pines, and junipers. Does that sound like any kind of vegetation that you're familiar with? Well, it should be, because it's all the foothills of the Sierras around you. Oak, pine, juniper forests. So during glaciation, when alpine glaciers were on the top of the Sierras, the vegetation down in the middle of the valley was most likely an oak, pine, juniper woodland. Now when we sample the calcrete samples, we get something very different. Yes, we still do have oak, and we still do have pine, and we still have juniper, but those three in the calcrete samples make up less than 1% of the total pollen spores. What's everything else? Well, what everything else is what's growing locally. And it's composed primarily of algal cysts. 70 to 80% of the pollen coming out of the calcrete samples are either algal cysts or freshwater dinoflagellates, things that grow in vernal ponds today. Also there are abundant herbs such as chenopodids, which today grow in dry playas, along with composites, little wildflowers, and palms and yuccas. So what's the vegetation like during the time the calcrete is being deposited? A very different environment than what we anticipated. Something that is dry and as hot, or even drier and hotter, than the Colorado desert in southeastern California. So we're talking about very warm and dry conditions, or conditions similar to what one finds in the Carrizo Plain, which is similar to the Colorado desert in aridity. So that's our interpretation of what the environment was like during calcrete deposition. So to summarize our working hypothesis, and this is only a work in progress, is that these periods of times in which the oxygen isotopes are telling us temperatures were much warmer than present, these were also periods of very dry environments, and that's when one would expect the calcretes. What we don't have yet, and which we obviously need, is dates. Caliches or calcretes are extremely hard to date because calcite is continuing to be added each year and each cycle. And so what you end up with is, at the most, a minimum age, because recent carbon has contaminated past carbon, so you can't use carbon-14, for instance. The uppermost calcretes we have dated by carbon-14, and they come out to be about 6,000 to 8,000 years ago. So about 6,000 to 8,000 years ago was our last drought. Not the one you're in today. This is a tiny blip on the radar. That one there would have sent Sid headed south, and probably Manny headed south. Everybody was getting the hell out of Dodge, I can tell you. But that's probably also true at the calcite, the calcrete that's at the top of the riverbank, and the one that's at the top of the Turlock Lake. The other part of the picture we don't have put back in is what these other calcretes are. When did they occur? What are their ages? So it's, again, a work in process, something we're currently working on. So my conclusions are that California has in the past experienced far worse droughts than we're currently in. So don't listen to any of that BS, that bad science, about this being the worst drought ever. During the Pleistocene interglacials, the Central Valley was most likely a true desert, that is less than 10 inches of rain. Today it's got about 20 inches. Up here you're probably more around 25 inches per year, and it would have been half or less of that rainfall in the past. The vegetation during these hyperarid periods included palms and yuccas and ephedras and cacti. Very little grass. Today we have about 10 to 15% of pollen spores that come from grasses or sage. And in the past, during these dry periods, we didn't even have grass or sage here. Practically no ground cover. So that's more similar to the modern Colorado desert in southeastern California. The only trees present were probably palms, along with a few things that are growing along the stream margins, the riparian taxa in the streams coming out of the mountains. The oak woodlands may have been present, but they were probably in the foothills of the Coast Range or the Sierras, and there actually may have been conifer-dominated trees, conifer-dominated forests, up at the highest elevations. And those mountain ranges then acted as refugia